Hello, my name is Nico Geraldo, and this is Lab 1 Charge Tapes for Physics 2. The purpose of this lab is to observe the interactions of charged pieces of clear tape and determine the excess charge on one piece of tape, and this will help me estimate the amount of transferred electrons between the tapes. The principles I used were Newton's second law and the Coulomb's law as shown below. And the results of this experiment were that the tapes repelled each other and they had a charge of 1.386 E-8 coulombs, and the tapes were deficient around 8.666 E10 electrons. My models and assumptions: I assumed that air resistance was negligible, and the long tape is treated as a point charge with the charge located at the center of the tape, and that the U-tapes have the same charge and the charge is evenly distributed along the tape. For my model, the charged tape or pieces of tape are represented as point charges with the same charge. Experiment details. My initial conditions were that I had 3 pieces of neutrally charged tape with 2 pieces having similar length. The third tape I used to stick to the desk as a base tape. My system is comprised of tape A and tape B, which were both U-tapes, and the surroundings were everything else. My procedure was I stuck a piece of tape to the desk for the base tape, then I stuck another piece of tape, which was the U-tape, to the base tape, and then ripped the U-tape off to create a charge on the U-tape. With this charged U-tape, I hung it to where it could move in response to different charged objects so I can observe the interactions between the objects in the tape. Then I made another U-tape to hang from 2 equally height objects. And then I held the first U-tape under the second U-tape and slowly got closer to it until the top U-tape started to rise. And then I recorded the distance. My observations for the different objects interacting with the U-tape were that the U-tape was attracted to the hand, the U-tape was attracted to the pen that I rubbed in my hair, and the U-tape was repelled by the other U-tape. This makes sense since I made them using the same way, so they would obviously have the same charge. But from this I gathered that the U-tapes had a positive charge. This is my code that I used. On the left you can see the diagram of the code. And the red point charge is the top U-tape, the blue point charge is the bottom U-tape, and the top U-tape is being acted on by gravity, which is shown by the green arrow, and the force of the electric field from the blue charge, which is going up, the orange vector. So for my data and calculations, the tape mass was 2.25 E-4 kilograms. The tape length was 22.5 meters. Tape width was 1.9 centimeters, and the distance between the tapes was 2.8 centimeters. So I found the force of gravity using the mass of the tape and the acceleration of gravity, and that's what I got. And the electric force is going to be equal to the force of gravity since after I get the U-tape, the bottom U-tape close enough to the top U-tape, it doesn't move anymore. So the acceleration would be 0. So charge of the tape is found by deriving an equation for Q from the Coulomb's law, and I got 1.38664 E-8 coulombs. For more data and calculations, I got the number of electrons lost by the tape by dividing the calculated charge by the charge of an electron, which I got 8.66648 E10 coulombs, or E10 number of electrons. The area of the tape is found by multiplying the tape length and width. Then I use the area of an atom to find the number of atoms on the tape, and then I found the atoms of tape per electron, so how many atoms of tape there are per electron. To start off our discussion, the problems with the model are that the tapes don't actually have equal charges, and that the tape isn't actually a point charge, which is an assumption I made for Coulomb's law. And then error sources following the problems with the model are that the tapes did not actually have equal charge, and that I actually lost charge due to holding the tape. What if electrons had positive charge and protons had a negative charge? What would you what would change about the observations you made with your tapes and other charged objects? Since all charges would be flipped, the interactions would stay the same. So the two positively charged U-tapes would change to negatively charged U-tapes, and they'd still have the same interactions. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? They will lose charge due to the electrons moving from the positively charged U-tape, or moving from my hand to the positively charged U-tape.